Hey everybody, it's Ripley back again. Apparently, making the font smaller didn't work out as far as dealing with skipping, so we'll just fight through it. We're going to talk about section 13.2, which is combinations and permutations today. Super simple, not a whole lot to it. There's just a couple of rules that we need to deal with. This idea of combinations and permutations falls under the blanket term of combinatorics. So you'll see this. Combinatorics. So if you see that in a math class or something like that, that means that you're going to be dealing with basically counting. That's all the combinations and permutations are. They are ways to count things. Okay? Now, it's real simple. When I teach this, I like to show this in a very simple, intuitive way. But we've got to have a little foundation first. Think about n factorial. Okay, remember n factorial is simply the number of ways to order n objects, which makes it real simple. I know this is review. I know we've talked about this. So let's say that I have 4 books and I want to arrange them on a shelf. There are 4 factorial, or think about it this way. I've got 4 spaces on the shelf. I have 4 ways to choose the first book. Once I've chosen the first book, there are 3 ways to grab the next one. After that, there are 2, and then there is 1 way to grab the very last one. The fundamental principle of counting says that since this is all going into one bookshelf, or one group, as it were, I multiply these guys together. All right? So that's really, really key. So let's talk about permutations. Permutations first. All right? So I'm going to write a problem. All right? How many ways can I elect? I elect a Pres and VP from a total of 5 kids. From 5 kids. All right. Now, think about that. So I've got 5 kids. I got kid number 1, I got kid number 2, I got kid number 3, I got kid number 4, and I got kid number 5. All right? Now, I'm not ordering all 5 kids. I'm ordering 2 of them. So think about it this way. I can make number 3 the president, and I can make number 5 the VP. However, this is a distinctly different outcome than if I make 5 the president and I make 3 the VP. So I'm not just grabbing 2 people from 5. I'm ordering 2 people from 5. Now, the other thing that I want you to realize is that insofar as the other 4 members are a part of the group of 5, their order does not matter. So it doesn't matter if I didn't get elected as a president or a vice president. It doesn't matter the order that I am not elected, as it were. So watch how this works. I'm going to do this strictly numerically and intuitively. All right, so here, watch what we do here. What we're going to do is we're going to take all 5 kids and we're going to order them. All right, so this is I'm going to take all 5 kids and I'm going to order them. All right, so that's the number of ways to order 5 things. There's only one problem. These 3 kids that didn't get elected have to be divided out of the group. So what I'm doing is I'm going to divide 3 factorial out of the 5 factorial because they're not part of the group. So what I end up with is the 2 kids that are left being ordered. Their order matters. So if I look at this is 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1. All these guys cancel, and I end up with 20 ways to elect a president and a vice president. And if you wanted to, you could go through and do it. You could go, let's say that the first term is the pres and the second term is the vice pres. I could go 1, 2. I could go 2, 1. I could go 1, 3. I could go 3, 1. I could go 1, 4. I could go 4, 1, etc., 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 all the way down the line. All right, and I would end up with a total of 20 when I was done. I already got 6, 7, 8, right? 1, 5, 5, 1. That gives me 8 distinctly separate outcomes. 1 is pres, 2 is VP. 2 is pres, 1 is VP. And then go with 2. 2, 3, 3, 2, 2, 4, 4, 2, 2, 5, 5, 2, etc., until we picked up all 20 of these. But what I want you to notice is the numerical way that this happens. I order everybody, and then I divide out the order that doesn't matter, the ones that didn't get elected. It's very intuitive in my brain. It may not be so intuitive in yours, but that's okay. You'll get your brain wrapped around it. All right, so check it out. There's a way to write this. Now, your textbook writes this like this, P, N, R. And what this means is the number of ways to order, arrange, elect, etc. Anything where order is implied are things from a total of n. From n. All right? The way I like to do this is NPR, because I can remember it because of the radio station. Now look at the equation. Look at what I did. All right? In this case, what I did is I did a permutation of 2 from a total of 5. This would also be written as 5p2. Now, look at this equation over here. 5 factorial, 3 factorial. So what did I do? I took 5 factorial, and then all that I did is I took 5 minus 2 and took the factorial, which was 5 factorial over 3 factorial. Notice, why did I do 5 minus 2? Because the 2 were the 2 people that needed to be ordered. The remainder were the ones that didn't get elected, so it didn't really matter. Now let's generalize that to this equation. Well, it's going to be n factorial, right? And then I simply go n minus r factorial. And I'm done. Nothing to it. Every single time. Now, let's deal with a couple things, then I'm going to show you how to use your calculator to do this. What do you think that, I don't know, let's go 5p0 is? How many ways are there, now intuitively, we're going to use our equation, but let's do it intuitively first. How many ways are there to order 0 things from a total of 5? Well, there's one way to do that. Don't order anything. Now, look at the equation. Let's make sure, because I could be lying. I take 5 factorial, and I divide it by 5 minus 0 factorial, which is equal to 5 factorial divided by 5 factorial, a.k.a. 1. Right? Now, how about this? How many ways can I do 5p5? Now, what am I going to do? This one's a little trickier. Think about that. I got a total of 5. I'm going to grab all 5 and I'm going to order them. Well, isn't that the same thing as ordering 5 books on a bookshelf? Wouldn't that just be 5 factorial? Well, let's check. I could be lying. Watch. This is n. Remember, this guy right here is n. This guy is r. So it's 5 factorial divided by 5 minus 5 factorial, which we know is 5 factorial divided by 0 factorial. We know 0 factorial is 1. So I end up with 5 factorial. Yeah. How about 5p1? Now this is a great problem. 5p1. What do you think? How many ways is there to order one thing from a total of 5? Well, now I don't have that pres, vice pres, vice pres, where I flip it. Think about that. In other words, I'm choosing one thing from 5 and I'm ordering it. Well, if I choose one thing from 5, it's already ordered. There's nothing else going into it. So I'm guessing it's going to be 5. Let's check, because I could be lying. Well, 5 factorial divided by 5 minus 1 factorial is 5 factorial divided by 4 factorial. And this is 5 times 4 times 3 is 2 times 1 divided by 4 times 3 times 2 times 1. All these guys go away, and voila. Isn't that nice? Okay, real quick, let's play with our calculator here just a sec.